Good afternoon, friends. So today we are into the fifth unit, that is Nano Composites. So as we are aware, yesterday we have seen the introduction to the Nano Composites. Okay, so this Nano Composite is nothing but extension of the composites. So generally these composites we have seen any composite material. Okay, so generally a tailor-made material is a combination of matrix plus reinforcement. So in this composite material, so generally it consists of two different material, that is matrix and reinforcement. Generally the matrix material is bulk material, and this is the additional material, and it is in a small quantity. Okay, so but here the bulk material is like almost either it is in a liquid state or in a solid state, but it is of the lower strength material, and this is of the higher strength material. But where we can see here, so here when we talk in terms of the composite, particularly, so here you can use the laminates. So laminates are like this. So you can have the different number of laminates. And when you club it, so this is the first layer, second layer, third layer. So in between you are going to have either the second layer can be a interface material, or it can be a one more layer. So now what is happening? So both together is basically a composite material. So here now the reinforcement can be either a powder or the laminate, okay, or whiskers, or it can be particulates. So when we talk in terms of this, we cannot have the nano size particles of this, all these are bulk material. Okay, so now in this nano composite we are going to reinforcement which is of a bulk material, so this we are going to use in the form of nano material. So generally this is nothing but 10 to the power of -9 meter, and if it is 10 to the power of -10, then it is called as Armstrong. Generally it is called as AMO or like this. Okay, so this reinforcement what we are going to add, so this should be in the order of 1 nanometer to 100 nanometer particle size. So if it is beyond this, then it is not a nano material. Okay, so here the range is in between the nano material. So here the bulk material what we are going to use, okay, so this bulk material, assume that this is the bulk material, irregular bulk material, or it can be a regular bulk material. So this bulk material has been reduced to the fine powders. So like this you can convert it like this. Okay, so this further reduced like this. Further it is reduced to okay. So this is the production of a nano size particle, where this has bulk size material. Similarly, this you can compare with the regular atoms, the bulk material, hexagonal in shape. So this is converted to smaller size. Further this is transferred to still smaller size. Further this is transferred to like this. Okay, so the production of bulk to the smaller size. So smaller the size of the particle, so better the properties, the surface to volume property. So now we can see we have converted the bulk material to nano material. So this, the particle size of the material, it should be in this order. So then only it can be a nano material. And the technology what is going to be used for this is called as nano technology. Okay. So now our aim, our objective is to get this size, that is 100 below 100 nanometer size. But the process is not that easy. Okay. So our objective is to main focus is on getting the products of the nano size particles. Okay. So now this is the composite material, and when we are going to use this 10 to the power of -9 or 10 to the power -7, then it is called as nano composite. So the advantage of these nano composites, like there are many advantages. So this is used in the medicines as well as biomedical applications. And this is also used in the aerospace for the coating. Okay. So this is used in the automotive for lubrication, lubricants and coatings. Okay. And this is also used as fluids, rheological fluids. This is used for treatment. Okay, so water treatment. Or environmental treatment. This is used for the beauty, that is beauticians. Okay, so this is healthcare. So like this, there are many applications of this process. Now here we can see this bulk material is of two methods. One is top-down approach, and bottom-up approach. So this top-down approach is nothing but this converting the bigger to smaller. So here bottom-up approach or bottom-down approach, bottom-up approach. So this is called as smaller to bigger. So now let us see here. So this is initially it will be of a bulk material, then it is converted to smaller size. Now let us see. Assume that all these are bulk material. It is taken in a container which is called as milling, which is connected on a shaft supported by the bearing. Okay, and this is allowed to rotate either in clockwise, okay, or in anti-clockwise, depending upon the requirement. Now, not only this is milled, in this actually there will be some milling will be there. So like heavy particles, these are the balls of generally metals. Sometimes they are also used ceramics. Okay. So now what will happen when I draw the side view? This is the drum. These are balls and these are the raw material. So this is the drum, that is cross section of this. So where there are n number of balls. So in this only there are particles will be there. So which will be rolling like this. Okay. So when the balls goes up and it falls, so here you have the raw material that will be broken up. So the bigger size particles are converted to smaller size. Okay. So this process is called as top-down approach. Now you can see like this is having a significant parameter. So all these are the process of manufacturing the powders. So all these are the process of manufacturing the powders. So if the speed is more, then what will happen? You get a centrifuge. So this centrifuge is nothing but there will be no breaking of the particles. So entire things moves simultaneously, and there is no production of the powder, and powder, raw material and balls both rotate at the same speed. Okay, so there is no variation of the speed, and because of this there is no impact. So that particular thing is called as centrifuge. So if the speed is reduced, then what will happen? The balls comes up here and it falls down. Because of this falling down, it crushes this powder. So the bigger size will be converted to smaller size. So by having the impact of the balls. So this process is called as ball milling. Okay. So this ball milling process is very, very important, and probably all of you would have seen the process of manufacturing the cement. So in the earth crust, cement is not available directly as we want. So it is available in the form of the ores. So we need to take the different ores like limestone, jelly, and the white cement. We need to take all those material and we need to process it and convert that into in terms of cement. So they are available in the form of ores and in the form of stones or lumps. Okay. So gypsum, limestone, all these are in the form of the stones or the lumps. So that has to be taken out in the drum. Okay. So this drum should be, so in the cement industry, if you can see, these drums are in terms of 2-3 meter diameter, sometimes even 5 meter diameter, and the length is almost around 10 meters length. So in that they dump all these bigger size raw material which are in the form of the stones or the ores. So then they also put these balls. Okay. So these balls are made up of, they are made up of the lead material. So basically lead is heavier in nature and it is very strong. So they put this material and they start the machine, and this is allowed to rotate from 80 to 100 RPM. Okay. So from 80 to 100 RPM this is rotated. So then what will happen? The ball, it comes up here and it falls down. So while it is falling down, it falls on this raw material. So these raw materials are broken into the smaller size. So it is grinded to such an extent, so where it is converted to the fine particles. So that particle size should come in the order of less than 100 nanometer size. So it takes lot of energy and lot of time to convert from bulk material to the powder size. So but one thing we can see here, the conversion ratio is high, but the efficiency is less. So because of the ball is impacting on the surface, what will happen? Even though your raw material is cylindrical in nature or having the uniform surface area, so this is converted to like this irregular shape. Okay. So because of the impact. So whenever the impact occurs, the uniform structure, okay, or the regular size the regular size is converted to non-regular size, so that similarity is not maintained. So suppose if I have around 10 grams or 20 grams or 1 kg of powder particles, so all the sizes are not same, the shape are not same. So we get variation of the shapes. So we can't have all uniform size like this or all uniform size like this. So there will be lot of variation because we don't have any control over falling of the balls from top to down. Okay, so this is what the disadvantage of this ball milling process. But this is the basic process to convert the bigger size material to the smaller size. Okay, so this is, we can, by this we can do the bulk sizing of the nano materials, from bulk material to the nano size particles. Okay, so if you want the in the bulk quantity or in the more quantity, then ball milling is the only option. So by this what will happen, now we can have the variable parameters like what ball size you can have and what speed it can rotate. Okay, so what happens if my ball size is smaller? What happens if the ball size is even smaller? So when you have the smaller size of the ball compared to this and this, no doubt this will give the better efficiency than this ball because the impact is less. But now we can see by this it takes lot of time. So here time is also a important criteria. So if I take the smaller balls and allow it to rotate for 1 hour, 2 hours, 10 hours, then what will happen? What the amount what it is removed from the bulk material is very less, but this is of uniform size. So in the same 1 hour time, if I am going to use this, then I am going to get the bulk material, but there is not uniformity in the particle sizes. Then we can have the combination of this and this. So what will happen? This will be giving better results compared to the bigger size as well as smaller size. So while doing this experimentation or the optimization process of the particle size and the particle shape of the nanoparticles, so we need to even optimize the balls also. Hence this becomes very significant. Okay, so that is what the advantage of using these different size balls. And the next is speed. What speed this should be rotated? If I am going to use the low speed, then the impact will be more and the braking will be more. Okay, so as a result of that, what will happen? The particle size homogeneity is not maintained. And what happens when this impacts with a high speed and high velocity from the top, then what will happen? This material, okay, the raw material get adhered on the surface of the balls. So then it becomes the micro weld. So the raw material get adheres on the surface of the ball. So this gets welded. So you cannot separate it out. So over a period of time, this raw material will become the integral part of your balls. Hence it reduces the efficiency of the impact. Okay, all these are the drawbacks. So what will happen? The agglomeration or the deposition of the bulk material will happen on the balls. So all these smaller particles are there, so they get agglomerate like this. Then though each one is a individual nanoparticle, but when it becomes combined with other particle size, then the size will become bigger than the nano. Again you need to break this. If I want to break this bigger size, again it is not possible, again they are merged. So this process is helpful only to certain extent. So beyond that region, you cannot use this ball milling process. But if you want to mix any two different materials, then ball milling is the best option. Okay. So now this is what the process of the ball milling process. So now next is this smaller to bigger size. So generally what will happen? So they are of the order of atoms. So all these smaller atoms by reaction, so that reaction can be either chemical or heat. Okay, so you can grow the material. So first the smaller size will be there. So the arrangement of atoms in a particular order and in a particular direction, so you can construct the nano particles. Okay. So the famous scientist Richard Feynman has said that there is plenty of room at the bottom. So the meaning of this is, so there is lot of future scope for these nanomaterials in future, because the MEMS, okay, Okay, so there was an interruption because of the power failure. Now I'm going to start once again. So this top-down approach is nothing but the process of breaking the bigger size and converting it to the medium and smaller size. So in this, a lot of the breakage will happen. So because of this, there is irregularity in the material is developed, and we can't get the uniform shape and size of the particle size. Now the next method is the bottom-up approach, where you are going to take the smaller size of the atoms, then nanometer, then you are going to grow it. Okay, so that the growing of the atoms or the molecules to a bigger size up to the order of 1 to 100 nanometers is called as the bottom-up approach. Okay, so now this is developing the process of carbon nanotubes. Again, in this there are two types. One is single wall, and there is second one is multi-wall. Okay, so there are a lot of applications of a single wall carbon nanotube and the multi-wall carbon nanotube. So to get the single wall carbon nanotube, it is very, very difficult, and you cannot maintain the uniformity. But whereas we can get very easily the multi-wall carbon nanotubes. Okay, so generally many people work on the research, so they generally develop the carbon nanotubes which are of multi-wall. So to get the single wall nanotube, it is very, very difficult, and the processing method also should be very, very accuracy and precise. So you should know all the backgrounds, the timing, the methods, or then only you can have the simple, that is a single carbon nanotubes. Okay, that is single wall. So now this bottom-up approach, so which is generally a chemical method like called as sol-gel process. Okay, so there is a solvent. When you dip in a metal, it reacts with the surface and that converts it into the powder. And that powder, again, if you allow it for a certain period in the system, then again it will agglomerate, again it will grow up. So as the time progresses, you need to keep on removing the material. So that is called as sol-gel process. Another 2-3 methods are there for producing this bottom-up approach. Now let us see this applications which is of the medicinal applications. Okay, so now whatever the tablet we are going to take, okay, so all these medicines, okay, maybe the liquid, that is syrups, or the medicine tablets. So all those in the tablets, all those particles are of the nano size particles. So you can see in the tablet which is written at the back side, so which is mentioning that 0.005 milligram or 0.1 milligram or 1 milligram, 5 milligram. So how do measure 0.1 milligram? Okay, and you can see in a small tablet of 5 grams or 10 grams, there are 5 to 10 ingredients which are of the order of 0.001 or 0.5, 0.2, 0.3 like this. Then how to measure that? If you want to go to the measure, then how to fabricate that? Okay, so there you are going to get the applications of the nano size. So all those powders of medicine, okay, when you put that tablet into the water, it dissolves. So that the dissolved particle size is lesser than the 100 nanometer. So in all these medicines, in the biomedical applications, so you can see these joints, okay, maybe the knee joint or a hip joint or a elbow joint, or sometimes whenever the fracture occurs, they put some rod, so which is of the magnesium material. So all these applications are of the nano materials. Next is aerospace. So when I talk the aerospace applications, the front cone of the aeroplane or the front cone of the spacecraft, it is coated with the nano-sized particles. So these nano-sized particles of the ceramics, in particular the silicon oxide and the titanium oxide, so there it avoids the friction. As a result of that, overheating of the cone of an satellite is reduced, and it is coated with a fine particle size material of titanium oxide, and that is the application of this nano coating. Okay. Next is automotive. So nowadays you can see these lubricants. So lubricants means oil. So in oil, okay, so earlier instead of oil they were using the water. So generally if you can see these 15-20 years old cars or old trucks or the buses, so after they travel 50 kilometers, 100 kilometers, they used to stop the vehicle and allow it the engine to cool, remove the cap and again top up the water, because the water is used to get evaporated because it is having the low boiling point. So every frequent intervals people used to top up the liquid or the water. So over a period of time particles have been developed and put into the water. So by this what is happening, the water what used to get evaporated, it was not getting evaporated. At the same time it is going to absorb the heat from the engine and it used to condense and then allow it in the atmosphere. So not only the cooling is increased, but amount of energy absorbed from the engine is also increased. Okay, so as a result of that, it avoids overheating of the engine. So like this, all these are advantages of using this coolant. So nowadays we don't use anymore water. Nowadays the synthetic coolants have developed and that we are going to use in the engine for the cooling radiating purposes. Okay, so on the earlier 15 years, 20 years back down the line in the Ambassador or the Premier Public car, generally they used to use the water. Nowadays that process has been gone on. So even yesterday we have seen this coating. So if you are going to take the paint which is of the bulk material and then you apply on the any surface, just if you take the tape, stick on it and just pull it, so that is called as peel off test. So entire paint used to come along with the tape. Now the same tape you put it on the any car and just pull it off, no paint is peeled off because all these processes are developed or coated by the nano materials. Okay, so because of that you wash, even after 5 years down the line, you wash the surface with the soap, then you wipe it off with a cloth, then the surface appears to be very shiny as if it has been purchased very recently. Okay, so that is the application of these coatings. Next is the rheological fluids. This is very, very significant. In present days, lot of research is going on this. So a fluid which acts dual properties in a single material. So it can conduct as well as it can magnetize. So earlier either it can conduct or it can magnetize. Nowadays you can have these rheological fluids which is used for multiple applications. So nowadays that fluid has come, just to mark here, draw a line of the fluid. So just to touch the multimeter here and other side it is going to get conductive. So this conductance level is very, very less, but it is going to avoid the physical wire. So people have done research on these rheological fluids. So next is water treatment. So in general purpose water treatment, that is osmosis, so we can see these water filters in all the areas. So even if you go to the hostels or hotels, or anywhere if you go, the water filter, that is RO filters, will be available. So what is this RO filter and what is the function of this RO filter? So it takes the normal water, maybe the water, the contaminated water, and when you put that water, so it filters out. So any size, bigger size particles or any dust particles which are present in the water, those are removed and it is filtered out and only the fresh water is allowed. So that process is called as osmosis, and here the major technique or the major technology what is used in this is nanotechnology, and the material what they are going to use is nano materials. Okay, so in water treatment majority of these filters are of the nano materials. So next is even the environmental. Now you can see this BS1 engine, BS2 engine, BS4 and BS. Nowadays we are going to merge it for BS6 or Euro engines. So what is this? So it is nothing but the filter. Okay, so whatever the particle size it is, the engine is generating, we can't avoid the generation of the or the combustion of the engine. So there the fuel is going to burn. So once the fuel is burnt, the remnants of the fuel, it is going to come in the atmosphere. So majority of the fuel is unburnt or it is having the polluted ingredients into it. So now we need to restrict that and we need to filter out. So whether it is burning fully or partially or mixed condition, so we need to develop a system such that in the pollution means the less ingredient comes into the atmosphere. Okay, so that is why engine is developed and it emits very lesser ingredients or lesser pollutants into the atmosphere. So again there lot of nanotechnology and nanomaterials are being used. So next is this beauticians or health. Now you can see a lot of advertisements comes in the TVs and even in the movies, and so many great actors give the advertisement of this face wash and face creams. So they say that become black, those who are black you can become white. So they can't physically convert the people, those who are black, into white. So what they are going to use is, they are going to use the face creams. Okay, so they use the face cream. So that face cream or the paste, what they are going to use, it's of the titanium oxide. So what it does is, it gives a layer of protection from the sunlight. As a result of that, our body is protected from the UV rays. Okay, so as a time progresses, so the black is converted to white. Okay, and it doesn't happen suddenly, it happens over a long period of time. Okay, so these are the examples. Even the paste, the toothpaste, what we are going to use. So that the toothpaste is, the particle size of that is the nano size particles. Okay, so by brushing with the toothpaste, our teeth are going to become white. So how it is going to possible? Because they are using the nano size particles. So because of that, the top surface is removed and they become white. So all these are the applications of the nanotechnology and nano materials. Okay, so I'm going to stop here. So if you have any doubts, any queries, you can call me and you can confirm your doubts. Okay.